the first question, right? The first question says, so I'm just going to add the page. First question, we're given that P, double implication, negation of R. We're going to say this. And then we have P, your negation of P down then Q or R. Q or R. Negation of P. Q. So remember last time I said that the best way for us to do this, right? We're gonna do this. Okay, let me take this. I think I'm receiving a call here. Yeah, so we're gonna do this. Remember last time I said that since we know that this is the hypothesis, this is the conclusion. We say right. We're going to first assume that these are true. You say right, and we must check whether this thing is true or not. You say right. So what we're gonna do, we know that first thing that we're gonna start with is this one, right? And given that when we assume that these things are true, in other words, you're saying that we are applying an idiom. Remember what an idiom is? A statement that is assumed to be true. So when now we can go through this flow step by step, and we see if we're gonna get to a true here before we write our argument. So we know that if we can say that this is true, if negation of P is true, it means that P will be false. We agree right now. And for this thing to be true, this one should also be false. That is what biconditional says. This should have the same truth value for this to be true. And if negation of R is false, it means that R is what? True. And if R is true, for this to be true, Q can either be true or it can be false. You see right now? This can be true or false. If we check there, the question that we're given is indeed like this. And this is true, false. This should also be false. And then this will be true. Then it means that for this to be true, it should either be true or false. So it means that this one should also be true or false. You say right. So the moment this becomes true or false, this will be invalid. So let's go to the question and do that. So when we come to the question, we're going to follow the logic that we had written here. So we restricted this logic. We're going to come and say this. We're going to say, if, I'm going to start with this. I say that if negation of P is true, then P is false. And then I must stop with a full stop. So remember this, after writing one statement to another, you must stop with, you must put a full stop. You say right now, then you go to another line. Now we say if, what do we have here? We have that is true. That is assumed to be true, right? So if we have P, R is true, and what we have from this, we have that P is false, and P is false, and then what will this be? It should be false also. You said that. So you won't make mistakes here if you first write this. You said right now, you know what this means. So you can just go through them one by one. R is false. I put a full stop. Now this, it can take me to this. You said right. So it means that I'll come and say, if negation of R is false, this one we know. If negation of R is false, then R is true. You say right now, then that will take me to this. When I get there, I know that this is true. So I'm going to come and say if. All statements should start with if. You see right now? If this is true, and what we know from that, we know that R is true. Then this to be true, for this statement to be true, this can either be true or false. Reason being, check. If Q is true and R is true, this can still give us true. If Q is false and R is true, this can still give us true. You see right now? So that should either be true or false. It will still give us true for both. So we must write it here. And then Q is either true or false. We stop. Now we know that this Q, we know the solution to that. Even though we have to stop because we've got the solution of true. That is either true or false. So we can come and say, hence the argument is said to be invalid, or not even said is invalid. Can not to make things long, right? Is invalid because we've already proven it. So we say that we are saying that now the argument is invalid because it can either be true or false. It should be one thing. You say right now it should be tautology, so it should be true. So we come to the second one. The second one, we start with this one. We can assume that this is true, true, true. So we start with this. This is true. If negation of S is true, we know that S is false. You say right? And if S is false, for this to be true, this thing can be true. For this whole thing to be true, this can be true. Because the moment true maps to false, it will give us a false. Remember with conditional statement, right? So it means that this is also forced to be false. This two, they'll be false. If this is false, it means that these two are also false, because that's the only way they can be false. So Q is false, we know. If this is false, also P cannot be true. Remember that right now. If true maps to a false, it will give us a false. So this will also be a false. Now that is false, this one will give us a true. So this is valid because the conclusion is true. You say right. So this will only be valid if the conclusion is true. So let's go through it. We write it on the other side. It's P implies Q. We have P so I'm not gonna write this. Let's see if I copied the correct one. Yeah, so I'm not gonna write their truth tables, right? So you'll write it because I believe that truth tables are simple, and we've done truth tables back then. So now we're just gonna focus on the argument. So it will be your job to go do the truth table, because I gave you this thing as an exercise last time we had a class, which has been last week, right? So you had a lot of time to go through them. So now we're gonna come to this. Let's structure what we decided that time that it will be valid. We say that this will be true. If this is true, this will be false. If this is false, this is also bound to be false, because a true can map to a false. It will give us a false. You see, right? So for this to be true, 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 this should be a false. And that is a false. It means that Q is a false, R is a false. So we know that Q is a false. Then this one can be true, because if a true maps to a false, this will give us a false. So we don't want that, right? We're going to avoid that by all means. So this will be a false. If that is a false, this will be a true. So we can now structure our argument. So structuring our argument, we're going to start here and start with the one that is alone. We say that if negation of S is true, then we know what is the solution after here, right? It means that S is false. And then S is false. Now check this. if S is false, then we'll know that this will be what? Will be false for this thing to be true. You see, right? Then we're going to come to another statement. We say that if this is true, and what do we know from this? And S is false, and S is false, then we know that Q or R is false. We say, right, we have said that here, that this should be false. So from here, if Q or R is false, then both R and Q are false. We say right now, both Q and R are false. This we know. Both Q and R are false. Now we know what Q is right now. So we come to the other statement. We say that if P implies Q is true and Q is false, we know that Q is false here, and Q is false, then P is false. Remember, P can be true. We have already written that here, that P can be true. Reason being is because if a true maps to a false, it will give us a false, and we're supposed to have a true here. Is that right? Now we say that if P is false, and then this we know, if P is false, then negation of P is true. You say right now. Then if negation of P is true, then we can say that hence the argument is valid. We say right, then the argument will be valid. Now we come to number 3. And on number 3, we are given P implies negation of Q by a conditional R, then therefore P. So we can just write this, right? We say that this is 3. So P implies negation of Q, W implies R, negation of P. So we can take that. We go, I think we'll need another page here. We need another page. Then we paste that. So now we can try to check if the conclusion will be valid or invalid. Let's check that. So remember, we check this one by one. So we know that if R is true, then according to biconditional, this should also be true. You remember, right? Double implications is that this can only be true if they're both true. So if for us to have this truth here, if Q is true, it means that this is false. And if this is false, this one is bound to be false. We know that. We have checked that from the beginning, that if true maps to a false, it will give us a false. So this is bound to be true. Now we are going to say if R is the true, always start with the one that is alone, right? Even if we know all these conditions now, we will start. The only way to get to the solution is if we start here. If R is true, then negation of R, even though I don't need negation of R, right, is false. I only need the R. And then we say that if Q by conditional R is true and What do we know from this? We know that R is true. Then Q is bound to be true. You see that, ne? So I'm not gonna write is bound to be. I'm just gonna write Q is true, because I'm not allowed to write a lot of words there. I must just put words like it's true, and then you say right, ne? Either, if I have either true or false, you say right. Those are the only things I'm allowed to write. So if we have Q being true, we can come and know that now from Q it will lead us to negation of Q. So we can come here and say if Q is true, then negation of Q is false. We say right, the negation of Q is false. Now since negation of Q is false, we know there now we can move to another one and say that if P implies negation of Q is true, and what do we know from this? And we know that negation of Q is false, then P is that P, right, is false. So P is also false. You say right. The reason being is because we can't have P as being true. If P is true and this is false, true mapping to false, remember, it's a false. So we can't do that. Now, if P is false, then negation of P is true. So now we see that negation of P is true. Now we have arrived to the solution. We can come and say hence the argument is valid because the conclusion is true. Like you see, our conclusion is a negation of P. The conclusion is true. So the argument is said to be valid. So we say that. Now we come to, let me see if I think we are almost there. We come to number 4. And number 4 says this. It says this is a different one, a bit, which is a nice thing. Number 4 says we have S or negation of R. We have P implies R. We have P and negation of Q. I'll just put it like this, right? You must use this one always. They just made them a typo. You say right now. So that is a typo. So you must always use this one. So now we come to the 4th question. So let's check what this will be. Let's say we come now to the hypothesis. We assume that this is true, true, true. We want to check now. All right. For us to check this, we're gonna start with this one. Reason being is because this is true only when T is true and T is true, and this only happens when you're dealing with like this. It's only one possible chance. That's only one possible chance. I can show you that. It's only one possible chance. So that is like this: 1 1 0 0 0 1 0 0 1 0 1. That only occurs for one possible chance. So this is 1 times 0 is 0, 1 times 1 is 1, 0 times 0 is 0, 0 times 1 is 0. You see, it only happens for one possible chance. So we're always going to start with and. You see, right? Remember I said that a statement that is alone and a statement that says and, these ones always have one possible chance. You see, right now, of being true. So this is 1 is to 4. So it means that we're going to start with that. We are going to say that if P and Q is true, then for this to be true, then both statements should be true. You see, right? And then both P and negation of Q are true. You see, right? Then those statements are true if this thing is deemed to be true. You see, right? And then now we say this. We know now we have that P and negation of Q is true. So let's see where it's going to take us. What do we need from this? We need P. So we already have P. We know that P is true, right? So we say that if P, so let's check, P is true. For this to be true, for this whole thing to be true, R should also be true because it can't be false. The moment a true maps to a false, we get a problem. You see that? If R is true, negation of R should be false. If negation of R is false, for this statement to be true, S must be true. It means that negation of else will be false. You see, right? So it means that this will be invalid. So let's just write it now. Since we already have all the syntax, we can just now put it down to it. See that if, what do we have here? If P implies R is true, and what do we know from this? We know that P is true. And P is true, then what is that? R is true. So R will also be true. If R is true, then negation of R is false. If R is true, then negation of R is false. We say, right? Then we now in that statement, if S or negation of R is true, and what do we know from this? We know R, negation of R, and negation of R is false. Then S will be what? True. And then S is true. So we have this. If S is true, it means that negation of S will be false. You see, right? If S is true, then negation of S is false. So having this now, that negation of R is false, we can say hence the argument is false. Yeah, and someone is knocking on my door. I'll be back. So now we can go to number 5, right? Now we have done 1, 2, 3. We've seen that it is not as difficult as it seems or as it looks. So we come to this one now. Here we're given this, this is 5, right? Here they say pretty either works in mine, pretty either works in mine or university, pretty eat KFC if and only if and only if she she doesn't work in mine. And then the last one is Pretty doesn't work in university. And then we conclude Pretty doesn't eat KFC. So we take number 5. We're going to compute it, right? So let's see. Okay, we can delete this. Did I delete the wrong page? I think I might have. Let me see. Delete. Oh. I think I deleted the wrong page here. I think I mistakenly deleted that page which I was writing solutions to. The first part, right? Let's see. I mistakenly deleted that one. Yeah. So let me just add the page. Now on 5, and I think it doesn't allow me to go to. Let me see. Maybe it will. Let me see if it will allow me to retrieve it. Let me see. It doesn't allow me to. Seems like once I delete the page, it's gone forever. Yeah, so we're going to paste this one, and then we solve it. Now we're given this, right? So first thing that you're gonna do here, you're just going to write proof. That's the first thing you're going to do. You're just going to write proof, and then you're going to have P, Q. Let's see if we'll have 3 statements. Let's start with 3. First, we go through these, right? We say Pretty Ada works in mine. So first thing we're gonna choose there, it's Pretty works in mine. We're gonna assign that to P. Said Ada. So you're not gonna write things like Ada, right? Pretty works in mine or in university. So Pretty works in university. And then let's see another thing. Pretty eats KFC. So we can give this Pretty eats KFC. Do you have anything other than mine, university, and KFC? No. So we can just start by writing this. Pretty eats either works in mine, this is P, or works in university, it's Q. Pretty eats KFC is R, if and only if she doesn't work in mine. So works in mine is P. So it means that if and only if, negation of P. Pretty doesn't work in university. University is Q, so this is a negation of Q. Pretty doesn't eat KFC. KFC is R, so this will be negation of R. So it means that this will be P or Q. R W implies negation of P and then this will be negation of Q, therefore negation of R. So already we know this. Once we are able to construct it to this statement, we know what's going to happen, right? So we know that this is true. If this is true, this will be false. And for this statement, remember we assume that these statements are true. For this statement to be true, this one must be true. You said that if that is true, this will be false. This will be bound to be false because of double implication. So this will be true. If negation of R, if R is false, negation of R will be true. So we know that this will be valid. So I want you to write this statement. Already we know how to write this statement. The main idea is how do you construct it? You say, right. So now let me help you construct 6. So I'm just going to construct 6 and 7 for you. Then actually I'm going to construct 6 only. You're going to construct 7 because I want you to also learn how to construct statements. So for 6, here they say Maggie. Actually, I can construct it from here and then you'll write it if you finish 6 and 7. Maggie went to the park. So it means that I was going to let the park be P or overseas. Maggie went to overseas be Q. If Maggie went to the park or cinema, this one will be Maggie went to the park. We know it's P or cinema. We don't have cinema here. So it will be or R. Maggie went to the cinema would be R. Then she eats burger. We don't have burger. PQRS. We also don't have chips. So this will be T. Maggie eats burger will be S. Maggie eats chips will be T. So this will be P or R implies S and T. Maggie didn't eat burger. Eats burger is what? It's S. So this will be negation of S. Maggie went overseas. To have overseas is Q. So this will be Q. Now we can check these statements if they're true or not, right? If this is true, this is false. And it doesn't matter what this is. This one will be false because false terms, anything is false. You see, and if this is false, this can be true because true can imply false. So it means that this must be false also. P is false. This can only be false if P and R are false. If this is false, this is bound to be true for this thing to be true. And this is valid. So you're just going to do this statement, right? You're going to do this. Let me just carry it and put it aside. You're going to write. So I want you to construct number 7. You're going to construct 7. And then we see from there. So this is what you're going to have. Right? You construct 7. You finish writing 6. You construct 7. You write. You're going to construct this 6. Using this syntax which I wrote for you here. That's right. I want you to use this syntax. Then here you write the solutions. That if negation of Q is true, then Q is false. Those things, you see, right? You're gonna write this. Then we'll be done. It means that we'll be done with arguments. We'll now go to predicates. We'll go to predicates. So yeah, I think for now we'll be done here. And then we'll look at, I'll see if we'll look at this when we come back. So, that means that next time when we come, we have proceeded. Just wanted us to do these corrections, right? Because these ones, there's no way you can't find a question like this. They'll always be there waiting for you to get those free marks. So you'll write them and goes those free marks on test 1. So also we'll come to predicate. It means that after predicates, we're going to the big concept, not these ones. Then this is a part of predicates. We're going to some big concept, which is method of proofs. Method of proofs carries a lot of marks, right? It's gonna take you 5. You know method of proofs. This will be where we'll be doing a lot of proofs. So if we know this, we do this in time. We do the tutorial. Let me see. I think this is the tutorial. We answer the tutorial, then we'll be fine. So I think we can stop here, guys. Then when we meet for our last session, I don't think we'll have time to do methods, since the last class which we're going to have will be based on predicates. So thank you, guys.